Since we're trying to cover the most important material between now and the end of the year, and we had to cut some things out, we're going to skip section 11.5. But there are some definitions from 11.5 that you need for 11.6 and 11.7. The first is a polyhedron, of plural, which is polyhedra. It's a polyhedron is a solid that is bounded by polygons called faces that enclose a single region in space. The polyhedra that we're going to look at over the next couple of days are mostly prisms and pyramids. So a polyhedron has polygons that are the faces. The edges, an edge of a polyhedron is a line segment formed by the intersection of two faces. And then a vertex of a polyhedron is a point where three or more edges meet. We'll look at these in the pictures in the next couple pages. For today, the polyhedron that we're looking at is a prism. A prism is a polyhedron that has two bases that are congruent polygons on parallel planes. When you name a prism, you name them by the shape of their base. We can have triangular prisms, we can have hexagonal prisms, we can have rectangular prisms, which a rectangular prism is also called a rectangular solid. And in 11.6, we're going to look at the volume of prisms and then also cylinders. The volume of a solid is the number of cubic units contained in its interior. And there's a couple postulates, statements accepted without proof to get us started. Volume of a cube postulate says the volume of a cube is the cube of the length of its side. If this cube has sides of length s, the volume is s cubed. The volume congruence postulate says if two polyhedra are congruent, then they have the same volume. They're going to take up the same amount of space. And volume addition postulate says the volume of a solid is the sum of the volumes of all its non-overlapping parts. You can break these figures into smaller pieces and then add the volumes together. So here we have some prisms. Again, this is a rectangular prism, a hexagonal prism, and a hexagonal prism and a pentagonal prism. And all of these would be right prisms. What that means is that the base would be perpendicular to these faces that go up. The faces that go up are called the lateral faces. And when you have a right prism, the two bases fall directly on top of each other in the parallel planes, and the lateral faces are all rectangles. And we can also have what are called oblique prisms, and we'll see those in a second. In order to find the volume of a prism, these are not formulas that we're going to prove because the way that they are proven is using calculus. So when you have a right prism, what we need to talk about is capital B, which is the base area. We use lowercase b for base of a triangle, or we did base of a trapezoid, but capital B is base area. So capital B would be the area of this entire rectangle. And then we need the height, which is h. So the formula for volume of a prism is base area times height. Now, in order to calculate the base area, you need to know all the formulas from 11.1 to 11.3 because you need to be able to find the area of a rectangle, area of a hexagon, area of a pentagon, and so on. When we look at a cylinder is not a polyhedron, but is very similar to a prism because it has two bases. In this case, they're circles that are on parallel planes. And again, this is a right cylinder because there's a right angle between the base and the edge. So in a cylinder, we can use the same formula. We can say the volume of a cylinder is base area times height. But with a cylinder, we know that the base area is only dependent on the radius of that circle. The base area is the area of the circle, pi r squared. Multiply that by the height, and we get a formula for volume of a cylinder. It's not really a different formula, but if you can remember it, often it's posted as a different formula. It's still base area times height. We have something called Cavalieri's principle. It says if you look at all three of these solids, all three have equal heights. Here's the height. And have equal cross-sectional areas B. So their cross-sections are different shapes. This is a right rectangular prism. This is an oblique rectangular prism. So you can see that the bases are not directly on top of each other. The angle here is not a right angle. So these lateral faces are now parallelograms instead of rectangles. So we have the mathematician Bonaventura Cavalieri, who claimed that all three of these solids would have the same volume because they have the same base area and the same height. And so his principle says if two solids have the same height and the same cross-sectional area at every level, then they have the same volume. So it's the base area could be measured at the bottom, but it also is a cross-section where you cut a plane parallel to the bases. Any cross-section would be equal in these as well. So we're going to do a couple examples finding volume. And this one is just talking about that volume addition postulate. When I have a solid such as this, I can break it up into two prisms. So if this was 4 and the whole length is 9, I know that this is 5, which makes sense with the 5 up there as well. So this is 2 rectangular prisms. The volume of a rectangular prism is base area times height. So if I look at the prism over here, my base is a 5 by 4 rectangle, and the height of that prism is 2. And then I'm going to add that to the area of the other base, and this, or the other prism. And this one, this is 4 and 4, that's 4 times 4 is 16. And I'm going to multiply that by the 5 height. And when I multiply all of that together and add it up, I get a total volume of 120. You can also do, no, we're going to go with that, 120. If there's no units given, you don't have to give units in your answer. You will have prisms where the base is one of the figures that we looked at earlier in the chapter. My suggestion is do not try to redraw the entire figure in your notes, just redraw the base. So you should have some diagrams that as you go through this, and in your homework, you're going to show all the work as you go. This 5 is the height of the prism. The 8 is the length of one of the sides of this regular hexagon. So we're going to put in the center of the hexagon and draw that right triangle like we did in section 11.3, where you take half of the side length, the apothem, and the radius. And in a hexagon, we know that this central angle here, the central angle is 60, so this is a 30-degree angle when we cut it in half. So this is a 30, 60, 90 triangle with a shorter leg of length 4, which means the longer leg is 4 square root of 3. So the base area, we can use 1/2 apothem times perimeter. The base area is 1/2 4 square root of 3 times 8 times 6. That's 48. Half of 4 is 2. This becomes 96 square root of 3 is my base area. So if I want to find volume, I'm going to take base area times the height. 96 times 5 is 480 square root of 3. And since this is volume, my unit is cubic centimeters. I'm going to ask you to leave all answers in exact form with these square roots in them, unless it's a problem that you can't do so. And it specifies on the homework. I think there's one that you cannot. Here's another prism. And if we look at the base of this prism, the base of this prism is a right triangle. It's a right triangle where the hypotenuse is 17 and one of the legs is 8. This is an 8, 15, 17 right triangle. It's one of the Pythagorean triples. If you didn't know that, you would use Pythagorean theorem to get the 15. And then you would find the base area. Base of a triangle is 1/2 base times height. And in a right triangle, the legs are the base and the height. When I multiply this together, I get that the base area is 60 square feet. So if I want to find volume, I would do base area times height. But in this problem, we're given the volume. The volume is 360 cubic feet. Our base area is 60 square feet. And what we need to find is the height. So we're going to divide both sides by the 60 square feet. And notice the units. When I divide cubic feet by square feet, I get feet. 360 divided by 60 is 6 feet. That's my height. Here, we're given the volume of a cylinder, and we need to find the radius. Volume of a cylinder is pi r squared times the height. And this volume is 72 pi. I'm going to divide both sides by 2 pi. You have to divide first, and I get r squared equals, the pi's cancel out, 72 divided by 2 is 36. When I take the square root, the radius is 6 centimeters. No, on this one, this solid, we want to find the volume of the solid. You can do this two ways. You can find the volume of the large prism and subtract the volume of the small prism, or you can look at the base as this square or rectangle with a rectangle cut out of it, and you can find that base area. That base area, this would be 4 by 5 on the outside and 3 by 4 on the inside. So the base area is 5 times 4 minus 4 times 3. The base area is 8, and this is square millimeters. So I can find that region first and then take that base area times the height to get the volume. Or you could do 5 times 4 times 6 minus 3 times 4 times 6. You have some options. This is not a right prism. This is an oblique prism. We can see that it looks like it's slanted. I always think of taking a slinky and pushing it to the side. And with this oblique prism, we can still find the volume because we can use Cavaliere's principle. Now, this base is a rectangle. Sometimes these diagrams are not the best drawn. The base is a rectangle that is 4 by 6. So the base area is 24 square millimeters. This is the height. We see it's perpendicular between the bases. So we're going to do base area times height to get a volume of 72 cubic millimeters. Last example, we have a cylinder whose volume is 64 pi, and the radius is equal to height. We want to find the radius. So our formula for volume is pi r squared h, and in this case, that's equal to 64 pi. The radius is equal to the height, so we can take out the height and replace it, substitute for height with radius. So on this side of the equation, I now have pi times r cubed equals 64 pi. Divide both sides by pi, and I get r cubed equals 64. You're going to take the cube root that's in the math menu on your calculator, and the cube root of 64 is 4, and the unit here is not given, so my answer is a radius of 4. Make sure in your homework that you are showing all your work, and then we're going to move on to pyramids tomorrow.